Observe what the people in the pictures above are doing. What did each one of them have to do in the actions of pulling, pushing, wringing, bending, lifting, and breaking something? What work did they do that made the object change its place or position? Had they not done it, would that object have moved? No object moves of its own accord. Force is needed to make an object move. What would you need to do to move the objects shown in the pictures here? A boatman uses a pole to set his boat afloat. The boat is pushed forward by pressing the pole. Oars are used to move it forward in the water. What happens when you apply the brakes while cycling? The rubber pads of the brakes rub against the rim of the bicycle wheel. As a result, the bicycle slows down. Force has to be applied to set an object in motion on the ground, in water, or in the air, or to reduce its motion. What does a spin bowler do? He lets the ball go after imparting motion to only one side of it with his fingers. While playing football too, the ball is given motion on one side only in order to change its direction. When you stretch a spring, its shape changes. So does the shape of dough when you press it. When you hit a ball with your hockey stick, it rises into the air. It means that force is needed to set a stationary object in motion, to change the speed or direction of a moving object, or to change the shape of an object. Try this. What will happen when force is applied to the things in the following chart? Carry out the actions and then put a tick mark in the proper place. Force. Shape changes. Direction changes. Object will move. Object will stop. Number 1. Handlebars turned while riding a bicycle. Direction changes and object will move. Number 2. Piece of sponge pressed. Shape changes. Number 3. Coin on a carom board flicked with the fingers. Direction changes and object moves. Number 4. A ball caught in the air. Object will stop. Types of forces. Muscular force. Who applies the force used while playing tip-cat or cricket? The players apply the force by moving their own limbs. The force applied using parts of the body like arms or legs is called muscular force. Force applied through the use of animals like bullocks, horses, elephants and camels is also muscular force. Mechanical force. Force applied by using machines is called mechanical force. Mechanical force is used in tractors, motor vehicles and other commonly used machines. Gravitational force. If we apply force and throw something upwards, it reaches a certain height and then falls down. Why? Because the earth pulls it towards itself. This force applied by the earth is called the gravitational force or gravity. As a result of gravity, the motion of an object thrown upwards gradually decreases and eventually becomes zero. After that, it begins to fall downwards. As it falls, its motion increases continuously. When we lift something, we have to apply a force against gravity. The greater the mass of an object, the greater is the force of gravity acting upon it. That is why we need greater force to lift things with greater mass. Try this. Take a small stone and a bucket of water. Drop the stone into the water from a height of 20 centimeters. Listen to the sound it makes as it plops into the water. Now, drop the same stone into the water from a height of 60 centimeters. Do you notice any difference in the sound? Why did the stone move? What was the force acting on it? Gravity acts on every object. This is the force that makes the stone come down from a height. As it falls, its motion increases continuously. The greater motion makes the plopping sound louder. Drop the stone from different heights such as 80 centimeters, 100 centimeters, 120 centimeters, etc. into the water and note the motion of the stone and the corresponding loudness of the plop. Look at the picture of the spring balance. A spring balance is used to weigh an object. The object to be weighed is hung from the hook of the spring balance. Gravity pulls the hung object downwards. At the same time, the tension in the spring exerts an upward pull on the object. So, we see the object swinging for a while. When the tension in the spring and the gravitational pull on the object become equal, the object becomes still. The gravitational force acting on it in this position can be read from the scale on the balance. This gravitational force is the weight of the object. Magnetic force. Try this. Take a magnet. Take a pin near the magnet. Make a note of what happens. The pin is pulled towards the magnet. Now, place 2 bar magnets on the table. Bring the north pole of one near the south pole of the other. What do you see? Now bring the north poles or the south poles of the 2 magnets together. What do you see? In the first instance, the 2 magnets get pulled towards each other, while in the second, they move away from each other. Where did the force that brought about the movements of the magnets come from? The force came from the magnetism in the bars. The force exerted by a magnet is called magnetic force. There are cranes in goods yards which have magnets. Magnetic force is used in cranes to lift heavy loads. The maglev train. Scientists have designed a train which gets lifted up above the track and travels with great speed in air. The maglev train is a recent application of the magnet. Its speed is 500 to 580 kilometers per hour. It makes use of the principle of magnetic repulsion between like poles of a magnet. Magnetic repulsion between the track or the guideway and the bottom of the train lifts the train off the ground. Thus, the train actually floats on air. A linear motor is used to propel the train forward. Maglev stands for magnetic levitation. The maglev train floats in air. This linear motor rolls on the guideway along with the train. As the train runs on a cushion of air, it makes no rattling sounds. At present, such a train is being used for ferrying passengers in some countries. Now, you must be wondering why such trains are not more common. It is very expensive to manufacture the special track and trains required. That is why it is not commonly used today. Frictional force. All the time we are doing things like holding something in our hands, walking on the ground. This is made possible by the force of friction. Try this. Place a ball on a smooth floor. Give it a gentle push. It moves some distance and then stops. Do the same thing on a rough surface. What difference do you see? Balls move, but it moves lesser distance than the distance moved on smooth surface. Try this. Run a 100-meter sprint and a 100-meter obstacle race. Play a game of carom. Find out where you must flick the striker and with what force in order to put the coins in the corner pockets. Repeat this after sprinkling the board with powder. The force required to flick the striker is less this time. While cycling, what do you do to stop the bicycle? From the above, you must have realized that a certain force acts between a moving object and the surface along which it moves. This force is called friction. Friction always acts in a direction opposite to the motion of the body. Friction between different surfaces is different. Try this. Rub 2 sheets of smooth paper one upon the other. Do the same with 2 pieces of sandpaper. Which pair of papers moves more easily? Smooth surfaces slip easily over one another, whereas some obstruction arises in the movement of rough surfaces. On the railway station, there are ramps or slopes in some places in addition to staircases. The surfaces of these slopes are deliberately made rough so that we do not slip while walking on them. On the other hand, the surface of the slide in the park is made very smooth because the very enjoyment of playing on the slide lies in slipping quickly down it. Try to recall other instances of surfaces made particularly smooth or rough. Reducing or increasing friction. We have to oil our bicycles regularly. Oiling reduces the frictional force between its parts and makes it easier to ride the bicycle. Bicycles and other machines have ball bearings. Their function is to reduce the frictional force and thus the wear and tear of the machines. When a car gets stuck in mud, its wheels turn without moving forward. At such times, a wooden plank is placed under the wheels so that friction increases. This helps the wheels to come out of the mud. In short, frictional force can be increased or reduced to suit a purpose. Static electric force. Try this. Spread very small scraps of paper on a table. Rub a piece of thermocol or an inflated balloon on a terylene cloth and bring it close to the scraps. Do the scraps move? Yes. Do the same by rubbing a plastic comb or pen on dry hair. Can you pull one end of a hanging thread using the pen or comb? Yes, we can pull one end of a hanging thread using the pen or comb. Rub a peacock feather between 2 pages of a book and see what happens when you bring it near your finger. In these experiments, we see that the thread, the peacock feather, and the scraps of paper move. What causes the movement? Rubbing causes electricity to develop on substances like rubber, plastic, and ebonite. This force, that is electricity, produced due to friction is called static electric force. It is a weak force compared to other forces. It is obtained by rubbing specific substances on one another. Guess the force that moves the fish. Cut out little fish from colored plastic sheets. Fix a small pin to each. Take some water in a wide pan and release the fish in the water. They will float. Take a magnet and move it over the water's surface. You will see the fish move. Use this idea to make some new toys.